Just trying to.
Recording
Okay.
in progress.
All right, so I'm gonna go ahead and start section 3.8, which is scientific notation. And this should not be anything new. You learn scientific notation in the middle portion of elementary school. I'm not sure how far back. But let's start with a little bell ringer, just to get our brains moving. So what I want you to do is I want you to write the following numbers, write in exponential form and standard form. All right, so the first one is 10 to the power of 2 times 10 to the power of 3. All right, so how would we write this? Simplify it in exponential form. In exponential form. So what would we do to our exponents? We would add them. So this becomes 10 to the power of 5. Now, if we write this in standard form, so standard form is where you write the whole number out. So that is equal to what?
10 times 10 times.
Okay, and then how do we write that?
10 times 10.
So here's my question. How many zeros are in 10 to the power of 5? So we look at 10. 10 has 1, 2, 3, 4, 5. So what number is 10 to the power of 5? 100,000. So this is exponential form. And this is your standard form. All right, so let's do another one. Now that we understand the process, if I have 10 to the power of 4 times 10 to the power of 4, excuse me. So what is this in exponential form? 10 to the power of 8. So the nice thing with any power of 10 is you don't have to multiply 10 times itself 8 times. You simply need to write your 1 and then give the same number of zeros as you have in your exponent. So how many zeros should I have? 8. Because remember, 10 to the power of 1 is just 10. So that's your 1, 2, 3, 4, 5, 6, 7, 8. So what's this number? 100 million. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 100 million. What about 10 to the power of 3 raised to the power of 2? What do we do when we have a power of a power? That's division. Division we subtract, multiplying we add. What do we do when we raise a power to a power? You multiply them. So this becomes 10 to the power of 3 times 2, which is 10 to the power of 6. So 1 and then 6 zeros. 1, 2, 3, 4, 5, 6. 1 million. All right, last one. 10 to the power of 7 divided by 10 to the power of 2. Now, what do we do with our exponents when we're dividing? We subtract. Now, only when the base number is the same, which in this case it is. So this is just 10 to the power of 7 minus 2, which is 10 to the power of 5. We'll go ahead and write that in standard form. So it's 1 and then 5 zeros. Again, 100,000. Okay. So scientific notation uses the power of 10 to rewrite extremely large numbers and extremely small numbers in a way that is neater. You don't have all of these zeros either before your number, if there's a decimal, or after your number, if it's a whole number. So we need to use very large and very small numbers, particularly when we're studying God's creation. So you'll see scientific notation used a lot in science class. Makes sense based on the name, right? So when we talk about the micro world, so bacteria and microorganisms, super teeny tiny things that you need a microscope to see, those are very, very, very small. So they're very, very small, represents very, very small numbers. And then we have the macro universe, which is your space and your astrophysics. And when you use these incredibly huge distances, or the size of things, then we use extremely large numbers. All right, so we call,
But here,
let me go and move on. Okay, so numbers such as 10, 100, and 1,000 are called powers of 10 because each one represents 10 to a exponent. And so multiplying, so these are the things to remember when it comes to powers of 10. Multiplying by a power of 10 moves the decimal place to the right. Yeah. So it moves it right. It makes the number bigger, right? So if I have 3.7 times 10 to the power of 2, then that's 3.7 times 100, which means that I move my decimal 2 places. So I have to add a 0, and that becomes 370. So your decimal moves right. That's why when they're all whole numbers, we have to add zeros. Can we talk about this at the same time? Okay, I got the lesson sort of splits it up. So let's just talk about multiplying right now. So let's look at a bigger example. I have 5.8 and I multiply it times 10,000. Then what we do is we actually, you want to write my steps here, rewrite 10,000 in exponential form.
is it 558,000?
It's 58,000. Yes. So your first step is you write it in exponential form. So we would write it as 5.8 times 10 to what power?
10 to
How many zeros? How many zeros do you have total? 4. So 10 to the power of 4. Just count the zeros. Remember, 10 to the 1 still is, that's that first 0. Okay, so it still counts. Now, based on that exponent, how many places to the right do I need to move my decimal? It should match the exponent. So I need to move my decimal 4 times. Let me go ahead and, so move the decimal, the number of times your, let's say number of times that match your exponent. That's what I'll say it. So in this case, we move it 4 times. So we take the 5.8. And I like to use the little like arrows. So 1, 2, 3, 4. So my decimal moves here, but we have to add zeros to represent each of those place values. And so that makes this 58,000. Now this is a nice and easy example because it's still a fairly small number compared to some of the super large ones. Now multiplying by a multiple of a power of 10. So let's look at this example. So if I have 0.12 times 4,000. So it's sort of a power of 10, but it's power of 10 times 4. So what we're going to do is we will rewrite that, separating out the power of 10. So this is where we use some of our properties of multiplication. So our first step is that we're going to here rewrite 4,000 as a multiple of 1,000. So let's see what that looks like. So that means that we're going to leave the 0.12 the same. And then we're going to multiply that times 4 times 1,000. Right? So now we have rewritten it as a multiple of 1,000. It's 4 times 1,000. Now we can apply the commutative property of multiplication. Hold on a second. They say commutative property. That's not the commutative property. That's the associative property. That's an error in the book. Okay, so you remember the commutative property means we move all the numbers around, but that's not what we're doing here. We're actually, so right now, order of operation tells us that we would multiply 4 times 1,000, but we want to change our order of operation. We want to multiply the 0.12 times 4. So I'm going to use rewrite. So don't copy what's in the book. So you apply the associative property of multiplication to change the order of operation. So that means that we're going to change it so that we multiply 0.12 times 4. Once we get that, we can multiply that times 1,000. So 0.12 times 4. Write it vertically. Don't try to do it in your head and get your decimal in the wrong place. So we know 4 times 12 is what? 48. Right. But how many, where do I put my decimal place? In front of the 4, exactly. So we've got 2 decimal places in our first factor. So we move the decimal to in front of the 4. All right, so this gives us 0.48 times 1,000.
I mean,
4,000 should be, right? But let's double check our work here. So we I don't think so. Let's see what we get here. All right, so I'm gonna rewrite. We could have done this all in one step. Rewrite 1,000 in exponential form. And so this actually gives us, I know this is a lot. This is just our example. It breaks it down. You are not going to have to break it down this many steps. You can do these kind of all at once. But how would we write 1,000 as an exponential form? 10 to the power of 3. Exactly. Then we can solve. So move the decimal point 3 places to the right. And that means, that means that 0.48, we move it 1, 2, 3, becomes what? Right, 480. That's why we don't do it. Don't bother doing it in your head. All right, so step 4, move the decimal place. 3 times. And again, we're multiplying, so to the right. Okay, so a very similar pattern exists when we divide by a power of 10. So let's look at this. Let's see. All right, so when we divide by a power of 10, again, like I said, we're going to see a very similar pattern, but it just moves in the other direction. So dividing by a power of 10, we'll just call that 10n, moves the decimal to the left. So the number's value gets smaller. I'm moving quick. All right, so let's look at an example. So if we have 84.2 divided by 10, then again, this is 84.2 divided by 10 to the power of 1. So we move our decimal one place and it becomes 8.42. So our first place value goes from the tens place to the ones place. So same number. If I have 84.2 divided by 100, well, we know that 84 is less than 100. So our answer is going to be less than 1. So this is 84.2 divided by 10 to the power of 2, because we have 2 zeros. So we move that decimal 2 places, maybe. There we go. And it becomes 0.842. One more example, but you can see the pattern here. 84.2 divided by 1,000 means that this is 84.2 divided by 10 to the power of 3. So we move it 3 times, 1, 2, but there's nothing in front of the 8. So I've got to move it one more time, add a 0, and then put my decimal there. So it becomes 0.0842. So you can see how these values just keep getting smaller and smaller. By exactly a power of 10. So again, when we divide by a power of 10, you move your decimal point to the left, the same number of places that is indicated by the exponent. So let's look at our example. I want you to divide 5.7 divided by 10,000. Super tiny number. So what do we do first? 5.7 divided by our first step. We rewrite 10,000 in what form? Exponential. All right, so what's 10,000 in exponential form? 10 to the power of 4, yes. So how many places do I need to move my decimal? All right, move the decimal, or in what direction? Left. Yes. All right, so we take, this one's a little easier because that division symbol is not in my way, but I'll rewrite it. 5.7, and I'm moving it 1, 2, 3, 4. So how many zeros do I need to add after my decimal? Three. So we have 0.3 0.00057. So tenths, hundredths, thousandths, so that is 5,700 thousandths. We would say that. Super tiny. So we annexed in our 3 zeros to write this as in standard form. So what I want you to do is work on skill check A. If you're watching the video, go ahead and pause it, work on 1 through 6, multiplying or dividing mentally, and let's see what you get. Okay, so let's see how you did. So for number 1, am I going to move my decimal place 3 places to the right or to the left? I'm multiplying, so I move them to the right. My number is going to get bigger. 1, 2, 3, right? Because I have 3 zeros. So what's my answer? 95. So for number 2, I'm also multiplying, but I don't have a power of 10. I have a multiple of a power of 10. So what do I first need to multiply times 0.31? A 3, right? I need to take this 300 is 3, not 2, 3 times 100, and I need that exact power of 10. So I've multiplied the 3 times 0.31, 3 times 3 is 9, 3 times 1 is 3. Now, I took care of the 3 out of the 300. How many zeros are in 100? And I'm multiplying, so I move 2 to the right. So my final answer, 93. Now for number 3, I have 7.42. And am I multiplying or dividing?
Multiply.
Right, we're multiplying. So I move my decimal to the left or the right?
That way.
To the right, yeah, to the right. How many times? 4, perfect. So 1, 2, 3, 4. If my decimal goes here, how many zeros do I need to annex in? 2 more zeros. So my answer is 74,200. Making sense? Okay, so for 4, 5, and 6, we're all of them are dividing. So that means our decimal is going to move in what direction? Yes, left. Our number is going, yes, I said left and I pointed right. Okay. So in number 4, though, do we have an exact power of 10? No. So we've got to separate that out. That's 2 times what? 10,000. So I multiply the 2 times what? Oh, you're writing. I'll let you write and I'll just talk about it.
It's
Times the 1.4.
2.
2 times 1?
Oh,
And 2 times 4? Yeah, this is nice. We don't have to carry numbers or anything. All right, so this is 2.8 times 10,000, which means I'm going to move my decimal how many times? No, I'm sorry. Wait, is this multiplication? It is. Sorry, I said it wrong the first time. This one is multiplication. So the number is going to get bigger. So that means our decimal moves right. How many times am I going to move my decimal?
4.
4 times. Perfect. 1, 2, 3, 4. So I already had the 8. So how many zeros do I need to annex in? 3. And that gives me 28,000. All right. So 5 and 6 are my division. When we divide, we move our decimal left. So in this case, I have 1.73. If I'm moving my decimal left, I have to count the zeros. There's 2, so I move it 1, 2. So my decimal goes here. That means I annex in 1 0 after the decimal. And my answer is 0.0173. Or 173 10,000ths. All right, number 6, they were nice enough to go ahead and give us our power of 10 in exponential form. So how many times am I going to move my decimal? 3 times. And I'm dividing. So do I go left or right? Right, correct. You go left. So 9, 3. So we go 1, 2, 3. We don't have to annex any zeros. I am going to put 1 in front of my decimal though. And it's 2, 5, 5, 9, 3. Oh, so 6,000. So it's 25,593 100,000ths, which is quite a mouthful. Just stay with me. All right. So the next topic is kind of the main point of this. Scientific notation. They have the definition for it at the bottom of page 134. And you don't necessarily have to write this down, TATION. I think the examples are even more important. So it expresses a number between 1 and 10. So maybe this is a little bit between 1 and 10 that is multiplied times a power of 10. So let me give you an example. So if you have the example 1.52 times 10 to the power of 8. Okay, so you have to look at this first number. Well, let me change the color so it's a little more obvious. This one here, it must be greater than 1. So it can't be 0 point something, but it also must be less than 10. So you can, if it's in proper scientific notation, you would never have 10.152. It would need to be, you need to move it over. So it's 1.0152 and then add a decimal or add a number to the exponent of the 10th power. And then this is always a power of 10. So it would never be 20 to the power of 8 or 30 to the power of 8. It would need to be a power of 10. So it's always in exponential form. All right, so if we write large numbers in scientific notation, we have something like example 4. Where we're asked to write, what is this? 25,300.8 or 25,308. No, that's 0.08, sorry. And 800ths. Mhm. Yeah. Okay, so we have to write it in scientific notation. So we start with our number. Where's my pens? Here we go. All right, so the first step is we move the decimal to form a number between 1 and 10. All right, so in the case of our number, we have the decimal between two zeros. And we need to move it. Are you still copying? All right. Where would I need to move my decimal to make this number greater than 1 but less than 10? Where do I need to move my decimal?
Say greater than 1 but less than 10.
Mm-hmm. So I'd move it right here
Yeah,
between the 2 and the 5. So I would write this number as 2.530008. But that's okay. Now, I have to multiply that times what power? Right, the same number of places that you moved it. So it would be 10 to the power of 4. So, move the decimal and then multiply. Well, let's see if I can spell, multiply the number. No, I said, if I can spell it right. Misspell, multiply the number by a power of 10. How can I put this? Well, count the place values, the decimal was moved. 10 should be raised to that power by a power of 10 that equals the number of places moved. In this case, it's 4. Sorry, that's a little bit weird. Okay. We will finish up with example 5 and do skill check B on page 135 when we come back on Tuesday. For now, this finishes the lesson for Friday. Thanks.